Thanks, iFixit, for that awesome teardown. What a way to celebrate Mario Day. And that's coming from me, Princess Ada, or is it Lady Peach? Anyways, now that we've seen what makes the Alarmo tick, let's take it to the next level. And we're going to hack this clock. We're going to open up. We're going to analyze it the way an engineer does with our engineer eyes. And don't forget to eat your power up mushrooms because this is where the fun part begins. Let's get these screwdrivers out, open this baby, and check out what's going on inside from an engineer's point of view. Okay, so I'm going to remove my Princess Peach gloves because they're very fashionable, but a very challenging thing to wear while taking apart this hardware. So I've already removed the tri-wing screw here. So now this just pops open and it comes apart very, very easily. And let's take a look at this. So, okay. iFixit already kind of went through and showed you a lot of the connectors and stuff, but let's kind of do a little bit of a deeper dive, maybe like underground world deep, into all of these components and sort of figure out what was Nintendo thinking when they designed this. So first up, we've got that USB-C plug. I really like that it comes from the back. USB-C, it's the way to go. It doesn't have the confusion of DC plugs. Is it +9 or +12? Is it 5 volts? Whatever. USB. Everyone's got wall adapters, and as we'll see soon, you can also load firmware onto the main chip over USB. So it's really handy as both a debugging and programming and powering system. We already showed off that coin cell in the iFixit video. That's the real-time clock backup. So that's what is used to keep time even when the main power is out. And this is a pretty big coin cell, that CR2032. So it'll keep the time for like 20 years, 5, 10 years easily. Next, we've got what looks like the power supply over here. Why do I think it's the power supply? Let's zoom in a little bit. Let's see if I can focus in on it. Okay, there's a couple parts missing, probably like, component swaps, because you can see this is also a power supply chip, but this is the BGA version, and maybe this is like a QFN version. Could be that they were sourcing multiple variants of that power supply. So this is a buck converter that's going to take that 5 volts from the USB and convert it down to 3.3 volts, maybe 2.2 volts, 1.8 volts. And let's go straight into boss level here. Okay, so this, boom, this is where all the brains happen. STM32H730. This chip has shown up in a bunch of Nintendo products. I think it's also used in their Game & Watch. It's not used in their like Nintendo emulator, that like classic Nintendo thing they made. But this is a great choice for a microcontroller. Why? It's got the ability to do really good graphics, right? Like STM is like well known for their STM32 7 series, lots of flash, lots of RAM, not too expensive, very dependable, really good development environment, lots of example code. Honestly, any peripheral you want to use, they're going to be able to support you over the STM series. Whereas if you're using some like weird knockoff, like edgy chip, you might have a challenge getting some of the peripherals attached, and we'll show you some of those why in particular the STM32 is really good. You can pick this up at DigiKey. We'll show this after the fact. So there's also like, this is the crystal. This is a 32 kilohertz crystal, I think, for the the internal clock. Now this part was under a little piece of foam, and I'll be honest, I actually couldn't immediately figure out what this is. It's got this kind of funky thing going on here. There's a lot of pins. I'll be honest, not sure exactly what it is. I tried doing some analysis real fast and like also looking up the part marking, but within like 20 minutes, couldn't figure it out. But what is interesting is, they covered this up with a little piece of black foam. And I don't think the foam, I think what that is maybe because it has like a chip scale, it could be light sensitive, and maybe the light coming from the TFT like was backfeeding to it. Another thing, it was I don't know what this is. Could be a security chip also. I could not find any record of it. And so I think that's what the foam was for, is just to protect it from light coming in and possibly confusing it. And then over here, so under there's a metal cap, which I removed. And this is an NXP chipset that provides Wi-Fi and Bluetooth. It's like a two-in-one processor, so it can, connect to the internet. You can put this on Wi-Fi and use that to get data. This is like new alarm programs. This is the PCB antenna. You can see the little antenna coming out here. There's a little Balin, like a Johansson part there. And then the signal comes out into this F antenna. You see the ground plane is cut away here. And they probably tried to get this as far away from the speaker as possible. Let me see where this is. Yeah, this is over to the right. So in the enclosure, there's a nice big open area here. So that's, not a bad place to stick your antenna. So this is interesting over here. This is like very, it's like, oh, is this, a part that got left off? Actually, this is the debug and programming port. And then if you look online, I found this post on social media on my computer. And this person, Tim, actually figured out, what most of these test pads do. Um, there is reset and SWD clock and data. So if you have an ST-Link programmer, like a $5 programmer, you could kick it up to here. The chip does have the security bit set, so you're not going to be able to like read the firmware off of it. However, you can always erase the chip and program in new firmware if you like. Like there's nothing stopping you from doing that. I don't think there's any security bit that would ever let you not program a chip ever again. But when you do erase it, like you lose all the firmware on it, and then you'd have to start from scratch. But maybe you could figure out what the pin connections are for all the hardware, and you could kind of like do your own runtime code. And there's people who've connected an SW debugger to this port, and then what you can do is over SWD, the debug wire, you can load RAM, you can load programs into RAM and then jump to it. So that's another thing you can do. That's a quick way to like side load code that you want to test out. There's also like power pins and then some like, UART, RxTX, whatever connections for this. There's probably also debug pins for that Wi-Fi port. Okay, let's go back to the overhead. Okay, so the interesting, they went with a standalone Wi-Fi chip, but again, drivers for this were probably available for the STM32. Like having a microcontroller that handles Wi-Fi is always a real pain. So if you have a reliable Wi-Fi chipset that your company knows is good, stick with it. Here's the little mini contacts for the left and right button. They're just like plain little contacts. And then you can see in the enclosure how the buttons are molded in. They're screwed in, they're molded, and then these little ribs poke down and press the left and right button. This this FPC goes up and into the RGB mushroom encoder. And as iFixit showed, it's a magnetic Hall effect encoder, which is probably smart. This encoder is going to be used a lot. And mechanical encoders, you do save a bunch of money, but they also have a lot of mechanical failures eventually. And probably Nintendo is like, look, people are going to use this alarm clock a lot. They're going to, use this to like set the time. They're going to use it a lot. Let's just go with magnetic. They probably have the sensors and the tooling, and maybe at the scale they've got, it's not that much more expensive than a mechanical encoder. And then there's also an RGB LED in here as well. Then this is a JST PH 2-pin connector, nice chunky wires. This goes to, probably a 4 ohm or 8 ohm 1 watt speaker over here. It's got a nice mount for the speaker, which it does have really good sound. And then over here, focus in. This is a Class D amplifier. You can kind of tell it's Class D because of the way it has these differential signals into the speaker. I2S input almost surely, and these are almost surely I2S test points. What is the exact chip? I don't know. It looks a little bit like a Maxim chip, but I don't know exactly which one. There's a lot of I2S, Class D speaker amplifier things out there. Next up is, although, yes, I think it's I2S. I don't think that this is an I2S converter and then this is just an amplifier. I could be wrong. Okay, then this big chip. So this big chip is actually a generic 4 MB eMMC flash chip. And this is what stores all of the programs. So what's interesting is I was reading about some hacking that happened with this chip. So this chip is obviously going to have this firmware, encrypted, like you're not gonna be able to read the firmware. But the eMMC is not encrypted, which makes sense. Like your file system is just, it has files on it, like images and bitmaps. And so you can dump this eMMC, which is just like, it's just basically an SD card, right? A 4 gig SD card. Either through the STM, like you could side load a program and have it like dump it out, or you can desolder it and solder it onto your own board and then dump it. But then this has a file system on it, and it's probably LittleFS or FATFS or something simple. And people have actually dumped like, here's all the images and the waves and the animations that are stored on here. And like I said, the STM32 is fast enough to read files off of here, buffer them in its gigantic RAM memory, and then pipe them out to the display. Speaking of, here's the display. Now, at first I was like, oh, this is a 40-pin connector. It even says like 40 on it somewhere. And there's a lot of pins. And I was wondering if it was, connecting over parallel, but I actually think it's like connecting over SPI because there's not a lot of, unless these pins are going underneath and into another layer. I guess I could look that up maybe over here. Yeah, like this row of pins might go under here. Yeah, possibly. And then this would be the parallel 8-bit connection. I was like, oh, is this like a TTL display? No, probably not. I don't think that's necessary because this is only like 2.4 inches. So probably either using SPI maybe, but almost more likely an 8-bit interface. Get very fast refreshes, very, very good look. And again, STM32s are really good at graphics processing. So that's the back. And then over here, I'm not going to take this fully apart because, I use this as an alarm clock, but also iFixit did a good job of showing off this. This over here is the 2.4 gigahertz radar. And that's how it does the detection. So what's cool about the radar is it's pointing out through the front right here at the top. I don't know if, yeah, like, it goes through, it's just a black plastic, but it's not, it doesn't stop the radar from coming through, and that's how it detects motion. And it has a couple axes, and it doesn't see you. It's like not a camera. It can't see what you're doing, but it can tell when there's motion, basically. And so, the same thing, the same technology that's used for, detecting, like radar detecting for speed cameras and stuff. Very similar technology, but obviously not nearly as powerful. It's like a lower grade of that capability. And then finally, the last thing I thought was kind of funny, the first thing I noticed when we got this Alarmo to do this teardown, and you can see it very clearly here, is that it's a round aperture, but the display itself is not round. And what's interesting is in the dark, it's very bright here because we're filming, but in the dark, you can't really tell that there's this cutout. And they kind of do this funny thing with the graphics where they sort of make it look like it's rounded. Like when they do graphics, they sort of round this area, and it kind of makes this like visual trick that makes you think that it's a rounded display, but round displays are actually quite expensive. Like this TFT is like $2 or something. It's not expensive. The expensive stuff here is the Wi-Fi chip, the eMMC, and then this STM32. The speaker isn't that expensive. Well, the PCB is kind of a nice PCB. But the TFT is actually fairly cheap. And, I think they got away with not having to get a very expensive, rounded display like we have. I don't know if I have any on hand, but anytime you have like a rounded rectangle or rounded display, they're going to add, it basically doubles or triples the cost of the component. Here's a small round display I've got hanging out here just coincidentally. But these are much more expensive than square displays. But I liked the idea of having these like visual hints for roundedness, but then the actual display was square. And then by doing a good job with the user interface, honestly, you think it's round and it has this kind of cute, friendly look to it. So a really nice mechanical and electrical design here by Alarmo. One thing that's, again, really cool about this is because you've got that USB port on the back. Hold on, I'm a little confused. this USB port in the back, there's actually a way to load firmware onto here. So if you don't want to take apart your Alarmo, but you want to run custom code on it, that's possible. I'm going to show that to you next. Okay, now that we know what's inside the Alarmo, the amazing hardware, it's time to do a little bit of hacking. Now, you could open it up and like we showed you, there's those debug pins. You can solder to them, connect your ST-Link or your J-Link or whatever programmer you've got and reprogram the chip. If you know how to do that, more power to you, more power up to you. But if you're like me and you actually want to keep using the Alarmo as an alarm clock, let's show you how to do some hacking that doesn't require you to rewrite the firmware or even open the device. So what's really cool about the designers of the Alarmo is they made it so that USB port on the back that's used for power, it's also used so you can upload firmware. And some very intrepid hackers, if you go to my computer, I'll show you this web page, have developed a way that you can um, read the key off of the Alarmo itself, and then brute force it so that you can load your own firmware, like side loading it through that USB bootloader. So I'm going to show you not the whole process, but a couple pieces of it, and then we'll refer people to the full guide. I'm also not going to be giving you the key, but honestly, I'll tell you, it only took me a half an hour, which is like less time than it is to beat Bowser, right? Okay, so to get into bootloader mode, let's go to the overhead and I'll show how this is done. Let's see if I can do this with my fancy gloves. Is you want to hold down both of these buttons, the mailbox and return, and also the back button. To be honest, actually push it down against the table. And with all three pressed, plug it into your computer. And then if you go to my computer, you'll see this the little mushroom at the top is red, and it appears as a USB drive. Now, folks who do microcontroller programming, this is going to be really familiar. You're like, oh yeah, that's right. Like you can bootload chips via USB these days, and so just get one of my free hands. I've already put together downloaded the files that you need. So the first file that you'll need is what's called the USB payload, and this is available. This is just a test to verify that you can side load firmware onto the device. And so first you drag on the bin file, and then you drag on the mark file, and it's going to actually have an error because it immediately reboots and launches the bin. So just click cancel, and then if you go to the overhead, you'll see what is suspiciously an adorable cat, probably the cat that belongs to the person who wrote this code. And then if you spin the wheel around, you'll see that the colors change, and then you can switch between colors and an adorable cat. And then if you click the back button, it'll show a QR code, and then you'll scan that QR code, and that will let you run the next piece of firmware, which again, I'm not software. I'm not going to show you, but I'll link to it. You take that number and then you guess the key. Again, takes like a half an hour or so on a computer, and then you can use that to compile Doom. Because hey, you know, when you have a piece of hardware that has an STM32H7 in it with a bunch of flash memory, like why not run Doom on it, right? It has a screen, has some inputs. So earlier, if you go back to my computer, I compiled the this person Gary also did a port of Doom, and if you have that key. You put it into the make file, you compile this, you put the doom.1 wad. And so now let's get back into the bootloader mode. So again, I'm going to do that 3-finger salute where I press the buttons and plug in the USB. Shows up as a drive. And then put over the compiled bin file, the firmware binary, and the generated mark file. And then on the overhead, dun, 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 it's Doom. So there's no audio yet, but you actually can play it by, hold on. I don't know how to, hold on. Let me see, maybe I have to reboot this. I'll say the controls are not very intuitive. Oh, and then one thing just to clarify, if you load Doom, when you boot it normally, it'll come back into the normal Alarmo firmware. So you don't have to worry about like, oh no, did I just overwrite my code? You didn't. Okay, so let me try this again. It's just like challenging with these gloves. Okay, so let's load the firmware. Skip. Okay, so this time. All right, so we got Doom running. And then yeah, knee deep in the dead. Okay, cool. Wait, I don't know if I can. Okay. So then to move around, you can rotate with the top um, encoder, and then you move forward by pressing the button, and then you fire with this button, and then this button is like the activity button. So if it's like you're opening a door. So let me see if I can. Okay, let's go. Bam, 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 bam. Oop. Ah, backwards. Okay, cool. Anyways, playing Doom on your alarm clock is super fun. So that's how you can do some quick hacking. And again, for more advanced uses, you can reprogram the chip. But this is really fun to do. And then, of course, you can use the code that would have been used to compile Doom, but you can run any firmware that you want that would normally run on an ARM core with the TFT display on it. And they've got the TFT interface code and the code for the buttons in the rotary encoder. So people can go out and hack their own interfaces and firmware that they want to run on their Alarmo. So there's some advanced hacking out there for people. So please enjoy your hardware responsibly. And this was super fun. I'm really glad I got to do this chance. I got to have this chance to work with iFixit to really get into the innards of the Alarmo and then make it play some old school games as well.